In this video, I'd like to give 3 examples of how to use what are called integer chips to represent numbers. In the first example, we are to use integer chips to represent the number 5, but we must do it in 2 different ways. The chips with the yellow plus symbol are considered to be positive, and the chips with the red negative symbol are to be considered negative. So if I am to represent the number positive 5, the easiest way to do that would be to drag 5 of the positive chips into the shaded area. Now I would have 1, 2, 3, 4, 5 positive chips, which would represent the number positive 5. Because I must do it in 2 different ways, you may start by repeating the same thing, dragging 5 of the positive chips into the shaded area. Teachers would like students to know that positive 1 and negative 1 sum to 0. So even though I want positive 5 and I already have 5, you could add another positive chip, but then compensate by adding a negative chip. And because a positive 1 and a negative 1 sum to 0, it's as if you added 0 to the problem. Since 5 plus 0 is 5, the combined value of the chips is still 5. So you could think of this as representing 5. These two combined can be thought of as representing 0, and 5 positives plus 0 would still be 5 positives. In fact, if you let me drag the plus over the minus chip, notice that they disappear because a positive 1 and a negative 1 sum up to be 0. But to make sure the computer can differentiate my first way with my second, I'm not going to drag one over the other and cancel it out. I'm going to leave it like this, click submit, make sure that I get full credit. The box is completely green, and I'd like to do 2 more examples. In this example, we are to use integer chips to represent the number negative 4 in 2 different ways. The most straightforward way to represent negative 4 is to drag 4 negative chips over to the shaded area. You can think of each of these chips as having a value of negative 1. But since there's 4 of them, the combined value of these 4 chips is negative 4. To do it in a different way, you may start by repeating what you've done over here. But if I leave my answer this way, I will be marked wrong because the 2 ways that I offer must be different than one another. So to make it different, I'm forced to drag more chips into the shaded area. If I were to drag another chip into the shaded area, say a negative for example, I would now have 5 negatives, which would represent a combined value of negative 5, which wouldn't be correct. Had I dragged a positive over, I would argue that a negative and a positive sum to 0, and we would only have 3 negative chips representing the value negative 3, which is still incorrect because I'm supposed to represent negative 4. Let me put the 4 negatives back together. Either way, if you drag a positive or negative, you'll have to drag the other as well. A positive 1 and a negative 1 sum to 0, so you can think of the combined value of these 2 chips as 0, so I basically added 0. Adding 0 does not change the cumulative value of the chips. So since this represents the value negative 4 and this represents 0, you could think of that as nothing. Combined, this will still represent negative 4. In fact, you can drag as many positive and negative pairs as you want. A positive and negative will sum to 0. So all I've done is rather than adding 0 once, is I added 0 a second time. And if you like doing so, you could do it a 3rd time and it will not matter. All I've done was add nothing 3 times, and none of this will change the combined value of the chips in the shaded area. This still represents negative 4. To show this, I'm going to click submit. Notice I received full score for the problem. In this problem, we are to use 1 or more integer chips to represent the number 0, and we must do this in 2 different ways. Leaving the shaded area blank will be marked wrong, as the directions are to use 1 or more integer chips. As soon as I drag either chip into the blank, I no longer have 0 anymore, so I must drag the chip of opposite sign over. Positive chip and a negative chip cancel. In fact, if you would drag one on top of the other, they would disappear, showing that they cancel, but then you'd be back to having a blank area. So let's drag one of each and leave them there. This chip having a value of 1, and this chip having a value of negative 1, the combined value of the chips would be 0. Because I must do this in 2 different ways, and because I can't leave it blank, and my second way must be different than my first way, I must have at least 2 chips, but then that would be the same as this answer, and that wouldn't be different. As soon as I drag another chip into the shaded area, I would again have to drag the chip of opposite sign. Now these 2 positives and these 2 negatives combine to be 0. I'll click submit to verify that I got full credit on both parts.